My friends, what I'm going to need you to do in a couple of minutes is jump to Schoology on phone or on computer. Go to Business Calc. Go to week number 8. And I have a limits review quiz that we can just kind of walk through real quick and just talk about it. All right, start new attempt. Let's see what we can do. And I'm going to do this, allow, enable touch. All right. Problem number 1. Hey. So once you find this, this comes down and it basically has some limits on it. Okay, so you just type in the limit thing. If the limit doesn't exist, the directions say write DNE. If it says infinity, INF, negative infinity, negative INF. So if you progress through this is just a review for the real one that's coming. But it's just go through the quiz itself, fill in the blanks, see how you do. Why don't you all take the first 15 minutes and see if you can do this as quick as possible and get it correct. And then I'll pull up your actual scores on the board and make fun of you. All right. Ready? So we're on the boards. So, excuse me, being gross over here. All right. So what was the very first question? It was, as x approaches -5 from the positive. So following my arrow, I'm going to -5. Gotcha? So as this follows along this path, so at -5, it gets to -1. That's the first answer. And then as we progress down, the next one says, hey, I have -5 raised to the negative. So that means I'm coming from this side. So that gets me to -2. So the bounded, dude, I'm losing my mind. Oh, there it is. So, being that you're bounding it from the left or the right, it can exist if it's saying come from the left or right. If it says, hey, I want to get to -5, and it's not raised to a plus or minus, it means the limit has to get to the same thing, and it does not exist for the third answer. DNE, yeah. And then we get down to letter D. It says, I am approaching 2 from the left side, from the negative. So as I come out here, I get to +1. Okay? And then I go down a little bit further. If I want to get to y from the, if I want to get from the left side, it comes down and gets to the same point. So as I approach this hole from the left and to the right, they both get to 1. That's the limit. Does the limit exist if they approach from the left to right and get to the same spot? Yeah, the limit as x approaches 2 is just 1. And I have to sneeze. Huh? Yeah. Okay, hang on. I got to sneeze, Alex. Hang it. Oh, it's the teaser sneezer. All right. So being this came from the left. I forgot to do the touch. Being this came from the left. This came from the right. They got to the same point of 1 and 1. That means this limit exists here, meaning I'm coming from both sides. So that one's up to 1. So 1, 1, 1, all the way down. Oh. Yeah.
That's crazy.
It's kind of opposite of what you think, right?
Yeah.
I get that. All right. Then, and then those are just where we put our answers in, right? Okay. Now we have this problem. All right. So, oh my gosh, I can't sneeze. I'm choking to death now. So I want to get from -1. If I want to come to -1 from the positive, I'm coming this way, so this gets all the way down to -5. If I wanted to get to -1 coming from the negative, it gets to -1. So the limit between those two won't exist because they want two different y components, but I don't think it asked for it. But then the next question said something that I should probably know, but I don't. Then the next one says, what is the function at exactly -1? At exactly -1, it has to be a solid point, so it has to be -5. Okay? Yeah, so when it says the function at -1, f -1, it has to happen at the -5. It cannot be this one. And then I don't even know what else it was asked. And then we have 7, and then, so 7 is wanted for both sides, so let's take a look at what that takes place. Okay, so now it just says we want the limit as it approaches 7. So I'm coming from both sides here. So I'm coming down, and I get to right there. That's 7, right? So that has to be 4. So that limit existed. I didn't have to come from one side to the other. I had to come from both sides, and it converged to the same point. So that's what we want. And then, what else did we do? So the function at 7 itself, also has to be 4. It's just the point right there. Okay, that a line is incorporated as billions and trillions of points. And then function at 2, f at 2 is a hole. Is there any graph or solid dots anywhere above or below the function at 2? No, does not exist. Okay. Yep, that works. Well, the problem I might count as wrong is we put DNE, and you might have put D space NE or DN space, or you might have put capital D, and like, in order for me to make it work, I have to go through like every iteration I think a kid could do.
Yeah, so it's easier to check it.
Yeah, I would go back. I actually go back through and recheck them. All right. Now we are on to problem number 3. All right. So, ready? So this first one, I want to get to -1 when I want to come from the negative. So think about like -1.1. Okay, so values that are less than -1. That means this plugs into the top one, so I can directly plug it in. So I get 7 times -1 is -7. So I get -5 for this first answer. The second answer says I want to come from the positive. So I'm coming from the right side. So where?
14.
Are we on B?
Yeah.
Oh, okay. I thought you were changing answers on that. I don't know what I said already. All right, so I have a -1, but I'm coming from the positive. Okay? So I'm going to go here, because the reason I chose this top one is think about this is like -1.0009. It's to the left of it. Now, if I'm just to the right of it, well, it automatically goes here, so that's going to be just 10. Yeah. Yeah, cool. And then, does the limit exist? Did these two give me the same exact answer? What was the answer to A? And the answer to B? 10. Oh, no, it is 14. You're plugging -1 in.
Yeah, so my
2 times -2 times -1. 14. So 5 and 14 Are 5 and 14 the same answer this week?
No,
Does the limit exist?
no.
No.
It counts correct as 14.
Did you get it now? Okay. See how easy it is to persuade Stirp to give you the wrong answer when it's even right? All right, so for letter A on this one, we can directly plug the 2 in. The reason I can directly plug it in is it's not going to give me something undefined. So 2 times 2 to the third power is 8. 3 times 8 is 24. 24 minus 7 is 17. For it comes out as 0.5. So on letter B, we can directly plug it in because I'm not going to get a 0 in the denominator. So you'd get 45 on top. You'd get 45 over 65, whatever that reduces to. Is that right?
I think so. I didn't know.
I think that's
45 over 65.
9 over 15.
Dude, which is 3/5, right? All right. Hey, friends, can I directly plug in letter C to get the limit? Will I get a 0 in the denominator if I plug 5 in? No. So I'm going to get 25 minus 9, so that's 16. 16 over 8, which is 2. Whoops. Sorry. Can I plug -2 into this one and get exact values?
It's
So it's -3 on top, on bottom,
-3.
It's -1.
or -1 on top, sorry. 4. Oh, it gets 0 on bottom.
Oh. Oh, yes. We'll change it. Where are you getting that? Okay.
Yeah.
What did the graph look like on Desmos at -2? It had a hole. X plus 1 over x squared plus 7x plus 10. Desmos. Graphing calculator. Over x squared plus, was it 2x or 7x? 7x.
I scrolled away.
All right, that's what our graph looks like. Yay, looks fancy. All right, and we want the limit of where? Of where? We have the limit as x approaches -2. All right. So as x approaches -2, this has to be a DNE. This is -2 right here. So if I come from either side, coming from the positive goes to negative infinity, coming from the negative goes to positive infinity. Limit doesn't exist on that one. And then, question 5. The degree on top and the degree on bottom are the same, agree?
Yeah.
So basically go 10 over 2. 10 over 2 is? 5. That's it.
So 1 is 5.
A is 5. Yeah, because 10 over 2, because the degrees on top and bottom are the same. On this particular one, as I get to negative infinity, you have to think, if I plugged really big numbers in and squared them on the bottom, I'm going to get positive numbers. So I'm going to get a really big negative over a really big positive. So I'd say this one would probably be,
D and E.
0.
I'm thinking of D and E.
what did the graph look like?
I think it.
X.
X. Asymptote.
X minus 1, x squared plus 2x. That's what it is? Okay. All right.
Oh, that's so bad.
X squared
Isn't it X minus?
plus 2x. Yeah. I was just x minus 1 on top.
Yeah.
All right. So, and we want to go which way?
Negative infinity.
Negative infinity? Yeah, it looks like 0. Because if I continue off to the left forever and ever and ever, it's going to get closer and closer and closer to 0.
So isn't it like if it's the exponent is smaller on top and on bottom, then it's 0?
It had to do with in algebra 2, the end behavior or the end behavior asymptote, basic idea. And then C,
I don't know.
what do you think?
I said 1, but it was wrong.
X squared. So if I plug in really big negative numbers on top,
What?
let's see what this one comes out to. I'm running out of board space. X squared plus 2x plus 2 over x minus 1. Oops, wrong way. All right, so friends, as we go to negative infinity on this one, I would say this graph is going to forever be heading on its way down. So I'd say negative infinity would be your limit. Negative, huh? Negative INF. And then last one, I think, as I continue to plug really big numbers in, my top gets really, really big. If my top gets really big and my small stays at 2, only place I can go is INF, infinity.
What was blank number 2?
Blank number 2. That one was 0. Cool. How did we do? Okay. So I think.
Oh, I got a 6 out of 10.
Oh, I have to go back and regrade it. So let me grade it tonight. That way you guys take a look at it tomorrow. Good enough. When I go